Good afternoon, everybody. I'm Joe Pryweller, Conference Director for Plastics News. I want to welcome you to the third in our ongoing series of Fireside Chats. As always, these discussions are fueled by Holland Company and organized by Plastics News. We are excited to bring you the newest streaming event to you live, where you'll hear us discuss topics of importance with leading experts in the plastics industry. You'll have the option to submit questions at any time during the Fireside Chat, and they will be answered in the order that they are received later in the chat. Just click on the Q&A icon on the side of your computer screen and then type in your question. We look forward to your participation and some compelling discussion. Today's chat surrounds the emergence of open platform 3D printing technology, an area that has the potential to revolutionize industrial additive manufacturing, and by virtue of that, operations across the board in the plastics industry. As all of you know, 3D printing is no longer an experimental technology, but an area that has taken off and become an accessible option for manufacturing companies of all sizes and in all industries, including plastics. And with the expiration of patents surrounding extrusion printing, the open platform 3D printing movement has really sprouted, making additive manufacturing more economically feasible and accessible for many companies. Today, we'll talk to a panel of experts who can help us sift through the many options for printers, software, and materials for open platform printing, discuss the opportunities, benefits, and remaining challenges, and offer specific applications where 3D printing has been a manufacturing success story. With us today are Justin Feinsilver, owner and operations director of the 3D Printing Store, a full-scale industrial 3D printing operation. Haley Ann Friedman, the global 3D printing engineering specialist for Holland Company. Peter Ho, an applications engineer for Ultimaker, which makes the largest open platform 3D printer in the global market. And Dan Lynch, Vice President of Engineering and Product Development at Composite Drivelines, and the owner of a privately held 3D printing service bureau in Milwaukee. Let me now turn the conversation over to our four speakers. As a reminder, to ask questions, open the Q&A icon on the side of your screen and type in your question at any time during this chat, and we will get to them later in the conversation. We'll kick off today's discussion by looking at the opportunities with 3D printing technology, some of which are less obvious. A recent report I read from Wohlers said that the additive manufacturing industry grew 21% in 2018 to $7.336 billion worldwide in sales from the prior year, with a huge 1.5 billion companies investing in the technology. As impressive, in the past 2 years, almost 530,000 desktop 3D printers were sold, close to double the number from 2016. Additive manufacturing is obviously a growth market, and one that many in manufacturing are investing ample dollars and time in. Why is that? And what are some of the obvious benefits and more hidden benefits, too, of open platform 3D? Let me start with Justin, who has a perspective on both open platform and closed source 3D printing. Justin?
Thanks so much, Joe. I appreciate it. Our perspective running a service bureau is kind of unique because we get to see a wide swath of customers everywhere from aerospace to industrial to garage inventors to kids to adults to retired aerospace engineers. No 2 days are the same. So one of the advantages that we really feel that open platform 3D printing tends to offer in our experience is that we are able to provide lower cost services based on material cost and machine cost, and also have a wider array of materials that are available for our customers to choose from in this open platform world. So it's really exciting for our customers. What we can offer them as a business is really unique as well. So we feel like in our space, it's a good position to be in, to be able to speak to these technologies and materials and provide better cost options for our customer base.
Let's get into some of the benefits with 3D printing. One might be cost, and that's maybe an obvious benefit, but one that's can be fairly dramatic.
Sure.
How are you seeing that as a cost differential with some of this?
Sure. I mean, for me personally, we see the materials are available now at a much more approachable price, and that's really valuable for us, as are the technologies as well. So it's really providing a lot more opportunities for our customers.
Hey, Leanne, I know we've talked a little bit about the variety of options that are available too in applications, material types, colors, and all of that. Has that expanded quite a bit? And what does that mean for somebody getting into 3D printing?
Yeah, and so to specify for everybody too, the closed source platforms are platforms that the manufacturer requires you to buy their own provided materials, and you aren't allowed to use anything else. So the traditional format of that only gives you, 3 or 4 or however many material options at insane prices for things like ABS or PLA that is a very low cost material. They're being charged hundreds of dollars for these spools. And the open platform really allows for you to take anybody's material and put it into your printer and utilize it, which is what Justin was talking about with the cost savings. So one of the main purposes and utilizations of 3D printing was to help bring manufacturers' costs down.
Sure.
And if you're being forced to buy these materials that are hundreds of dollars for something that shouldn't be, it's not as competitive as it could be, and it takes away a lot of your freedom.
There's been slicing software too that adds to that also, I understand, right?
Yeah, and so the open platform allows for you to modify significantly more things about your part. They lock a lot of the features that you would want to be able to utilize in engineering to make your part more effective or change the geometry or the way that it might be built. But the open platform, you can change probably too many things about your print. You could change literally anything, and that really, really opens up the possibilities.
What just for our audience out there might not be aware of it, what are the differences between open and closed platforms? What does that mean exactly?
So
and how does that affect companies?
The material availability is the biggest portion of that. So they'll take a machine and their slicing software will be proprietary to them. That will only enable them to use those chipped materials. They'll usually attach like an RFID chip to the actual spool, or something along those lines where it literally will not function if you put anything else in it. An open platform, you can buy absolutely anything and run it through your printer. So it's more like an actual machine tool or anything else that you would use on a machine shop floor in manufacturing.
And I imagine, Dan, that would impact you running a printing service bureau in Milwaukee, that kind of thing, where you can deal with a lot of different customers, right?
Yeah, absolutely. We deal with a number of customers. It could be as simple as changing the color or the material properties of something. And, if somebody wants something in a sky blue, we have the availability of finding that and sourcing it, usually getting it within just a couple of days. If you used a closed platform system, a lot of those options would not be available.
Yeah, so you can do a wide gamut of
absolutely
applications they may not have been doing in the past. And I imagine you're seeing that too, Justin, with a 3D printing store with some of the areas. Are you seeing new customers and lots of applications you might not have thought about in the past with this?
Absolutely. We have a gentleman who wants to remake of his favorite insole that's no longer available from a large company. And so we 3D scanned it, we printed it in an engineering plastic that's flexible, and now he buys 10 sets a year. So you're starting to see a lot of, and to speak to color, he wants different colors for different shoes. So having that capability and that flexibility really gives us, like a wide set of offerings.
Great. Let me get the equipment side into with Peter at Ultimaker. How about equipment options? Are there some advantages to create entire products, or any kind of equipment that's needed with this that may not be able to do in the past?
Right. So with an open platform 3D printer, you have a huge versatility on exactly what sort of applications you can do. So you can do end products designs, or you can do something along the way, like manufacturing tools, other types of aids. But going back to the open sourceness, being able to choose your material allows different companies to really get into a product design and have a lot more time to work on the products and not necessarily have to wait for external sources for that. So I'm working with this company that does aftermarket car parts, right?
Mm-hmm.
So motorcycles, hot rods, rally cars, and they're using 3D printing to do end-use parts that's actually going to be used on the vehicle itself. So one of the things that they're doing along the way is doing form and fit testing. So if they want to change it, they can easily just print out a new thing, and then once they have the new thing, they can print it in the final material and that final material can be based on what they want in terms of properties. So, for example, motorcycle grips need to be a softer TPU. A dashboard can be the same type of TPU. Like tail lights, headlights, those need to be more translucent, but they need to have more temperature resistance because they're right next to a light source. So being not locked down to certain materials allows them to really blow open their entire potential.
And you can use certain pieces of equipment separately for different types of applications too?
Yes. So the equipment you use, basically, you're either doing the end use part, right?
Right.
Or you're doing jigs and fixtures. You're doing, functional prototypes, and that's all coming from the same 3D printer.
Sure.
But you're printing different parts for different equipments along the way.
Huh. So that's even more versatility than I had in the past, going back to what Haley Ann was talking about with the versatility of this, as well as along with colors, which you haven't really talked about, and a variety of different areas that you can do with anything, right?
Yeah, well, and a lot of people do want to try and, for the functional prototyping purpose, a lot of people think that, a plastic injection molded polycarbonate has the same properties as a 3D printed polycarbonate, which it doesn't. It's a different process.
Okay.
So being able to use different materials and different formulations and even different machines, because you're going to get marginally different properties from one machine to another, will allow you to better mimic those properties of your final use part if you are utilizing it for functional prototyping, so that you can actually test it effectively.
No. So there's a lot of work you can do to test different colors, different materials, see what works the best for your application. I guess that's the advantage of it in prototyping and getting to what you need with your finished product, right?
Yeah, exactly.
We talked about some of the obvious benefits like cost and flexibility with this, and versatile equipment that you can use. But there's some other benefits and applications that are less apparent, possibly. One of those we know is really big in the plastics industry now is finding and retaining top talent in the industry, especially getting young people to join the plastics industry is a big concern for anybody in manufacturing at the moment. We talked a little bit about generally how the advent of this at a company could help some of that. Does anybody want to talk about that a little bit, about the use of this and helping to attract young people to the profession?
Sure. Yeah, I would love to speak on that.
Great.
So in our experience, we have not an official internship program, but we do have quite a few young interns, even as young as 12 or 13 years old.
Wow.
And they are, and if that should be anything.
12 and 13, so they're middle school age?
Yeah.
Jeez.
Yes, don't tell anyone. But the advantage of that and what we're seeing about these students is that they're design capable, which is really interesting. These aren't students that have gone to college yet, who have had 4 years of CAD programming or things that you might need in this industry. It's really interesting to see that they just kind of get it. I don't know if it's from video games or what their experience is, but they understand a 3D world sometimes better than even I do, which is really interesting. So with 3D printing, a lot of libraries, a lot of school districts are really making a big jump into this because I think they view it, and the schools that we talk to on a regular basis view it as an opportunity to kind of get kids making things in the 21st century. It's kind of replacing or enhancing the wood shops and the tech schools of the world that exist now. But interestingly enough, we were part of an event in last week where we had the students design drawer pulls, doorknobs.
Doorknobs.
And we had fourth grade students design door pulls that were 3D printed and presented at a presentation. And we had a university professor who attended the program, and he said, "I'm not ready for these kids. I currently am not ready for this." But it's interesting to think about how this industry is going to continue to grow with students that age, because they're seeing, touching, and feeling it. And it's really important that they are exposed to it and understanding that anyone can really make things now. Now, there are some challenges and bumps in the roads we'll talk about, but it's really impressive to see what they can do even at that age.
So if you like playing Legos when you're younger, you're probably going to like to get into 3D printing later on.
I think it's an easy jump. Yeah.
Absolutely. So one thing for me that I think is going to be very useful is that you can take an online design or come up with your own design using free CAD software and then actually just print it. So I think that's very interesting for a younger kid or somebody that's interested in design, because you can have something in your head, put it on in a computer, and then a few hours later have that physical part. And that allows you to say, oh, you know what, I made a mistake here. We're going to make these tweaks and then come back with an enhanced design, again, very inexpensively and very rapidly. So I think that's a great way to get younger people involved.
Great. So that makes manufacturing sexy again for some of these younger folks that might look at tech industries or something else anyway, right?
Yeah. And again, going back to the various materials, is now you can get things with like a high concentration of wood. So you can have your wood shop class now being printed, which is a little scary, but you can do a lot of really cool things.
Yeah, that's great. So, and you brought up a good point too. We here with talent retention, you almost have to start young, like by grade school, or at least by middle school, they already have a path form in their head of what they want to do, at least generally, even though it might not be specific. So you want to get them young with this. If they're starting this, implementing this even sixth grade or seventh grade or something, I imagine that's key with some of this.
I think that's huge, because I always say that I really wish somebody told me that I could be in manufacturing when I was growing up. That option, or even engineering in general, was never presented as an option. It was, here are these different paths that you can go on.
Sure.
And I think a lot of people either fall into it, or, parents have some influence there, but it's not talked about enough as something that's exciting. And manufacturing is really cool.
Yeah.
But and everybody's always going to need it. It's an incredibly lucrative industry. It's very interesting, and people just need to know more about it at a younger age and understand that it's a very viable option for careers.
Yeah. And kids like to go to the computer lab or be on their computers or design things. So it makes manufacturing fun, and not just rolling up your sleeves in the plant and putting together parts.
Yeah.
So,
Right. For us at Ultimaker, education is one of our biggest markets.
Really?
Being able to get into a school and develop a curriculum for them so they can print out, a design that they made themselves and have it in their hands like a couple hours later is really beneficial, because otherwise a physical thing speaks a lot more than just something on a piece of paper. And having them being able to do that just launches them into a STEAM education type role, and then brings them into this manufacturing world.
Some STEM schools involved in that too, and other specialty programs doing this also, I would think. Another area that I know is key right now, at least in the OEM world, is getting parts to market faster and using innovation. And obviously they want their suppliers to react quicker and in a more agile manner to get parts to market anyway, and using innovation at the same time. So I imagine, Dan, you're not. I know we were talking about this a little bit. How can that be a benefit with 3D printing?
Yeah, absolutely. So the 3D printing company that I guess I own, the biggest challenge for me is that originally we started off just printing parts for people, but we've turned into much more of an engineering design company that uses 3D printing to actualize people's ideas. And what we're finding is that a lot of people don't know what they really want. So if you're able to interpret their explanation for something and then give them a physical part, they usually say, well, that's not what I had in my head. Can you change it in this way? And you can rapidly innovate, you can change things very quickly, and give customers an idea of what they would actually be producing in large scale. So without investing any money in tooling, without even looking at suppliers, we can have a much more optimized design very quickly.
And that goes back to the cost point too. You don't have to pay a lot of money for a metal tool right away. You know exactly what you want, and get to that point too. And you do a lot more upfront work, I guess, right?
Sure. Yeah, it's you're doing a lot more CAD design work rather than, I guess, redoing tooling and things like that, which of course is beneficial cost-wise.
Oh, absolutely. But you see a lot of customers that way that want to. I imagine their customers want things quicker, want to know that they're working on something innovative. I imagine yours too at Ultimaker would be that way.
Yeah. So talking about the metal stuff, like without having to go back to the machine shop and each iteration, or going back to an external supplier or something like that, you can, print out your piece. And if it's not right, if the customer says, this needs to be bigger or smaller, you can just redesign that right in CAD, print out another one for just the cost of whatever that plastic is. And then once you have it correct, you can do things like, then go out to machine that, or maybe you make a mold of it using, certain processes like lost PLA casting, where you just burn out that PLA plastic piece, and now you have a mold that you can make a metal part out of that. So really, you're saving so much time and energy without having to go through all these metal fabrication processes right with 3D printing.
Yeah. Molds are expensive, and the last thing you want to do after you've designed a part is, pay all this money for a mold, wait 4 weeks for it, get it, figure out that it's wrong, and then do it all over again. Utilizing 3D printing in almost every case can help speed up your time to market and how long it takes for you to actually create the final part. Testing it, of course, to make sure that it works, but the tooling is a huge portion of that.
And another area of manufacturing too is a lot of companies worry about the issue of working in too many silos, where one area of the business doesn't talk to the other area of business. Manufacturing engineering might not talk to design, might not talk to marketing, might not talk to some of the other areas. And I understand 3D printing may be able to fuel that collaborative process a little bit. Also, would have different people talk to each other and communicate and come up with the best area, right?
Right. So 3D printing is a great communication tool, because sometimes you say something with words or even a picture and it doesn't really mean anything. But if you print it out and show the marketing person, you show the executive or something, this is what I'm talking about, then it gives a much better grasp on what the project is. And you also have the ability to have a digital file. If somebody at a site 1,000 miles away wants that same thing, you can just send them the file, send them the exact settings. I use this material, I used these settings, and they can print the same exact thing without having to ship or wait.
Yeah, so they might be able to make their own CAD packages they can send out, and any kind of equipment modifications can be shown right too in some of this.
Exactly, it's just uniform throughout the entire organization. This is the file, and that's it. It's digital fabrication.
So you can add the use of different materials to it too, and see what works best, or colors, or whatever it happens to be.
Yeah, absolutely.
Yeah, that's big. So that gets people talking, and maybe in one room then to do different things anyway. The last, and we get into this a little bit with cost, is sustainability, obviously, and that's energy savings with some of this, and less material used. Could we quantify some of that, or know exactly how does that work as far as savings go, as far as sustainability goes, as far as saving some of that? And Haley Ann, do you want to take that?
I suppose in terms of material savings, if you're comparing it to traditional machining, you'll often start with just a block of material, and you're utilizing subtractive manufacturing, where you're just taking away until you have the final part. But in this process, because you're taking a material and adding layer by layer, the only waste per se is going to be your support material, or if you had a failed print. But you don't have all of this useless wasted material at the end of the process. So there's quite a bit of savings there. There's also how you're able to build the internal portions of the part. You can do quite a bit with actual weight savings and material savings by utilizing different types of infill. So if you want your part to be 100% dense, obviously you'll utilize more material than if it was 30% dense or 50% dense with an infill percentage.
And again, you can test, and as you see with your customers too, you can test some of that out and see what might be best for savings.
Absolutely. And then it gets back into the functionality piece of it too. But our customers are really interested in the idea of, when I can tell people that I don't have to make this solid. And they are like, I don't understand what you mean. And I'm like, well, I have the capability with 3D printing to be able to create things that, just are made in a completely different way. So it's giving that advantage to the thing that we do for, in that sustainability, speaking to that as well. When we're testing a tolerance or a fit, I can print an inch of it. I don't have to make a whole part to test everything all the time. So I'm fitting something onto something or into something that's not 3D printed or even is. I usually will test a portion of that to make sure it fits. That way I'm not wasting a whole block of material, or even a whole 3D printed part that doesn't fit. So it gives an advantage that way.
Well, let's get into a little bit of the process end of this. I mean, and Justin, maybe you want to start some of that. We talked a little bit about the digital CAD file that can be sent to different places, and also you're ready to slice. You can use any software you like, but what's the actual, for someone who might not be as aware, what's the actual process involved in this? You use Ultimaker, so Peter can jump in on this too, obviously. But
the standard process generally starts with a CAD file, wherever that's obtained, whether it's designed, whether it's something the customer designed or had provided to them. In our process, we're always going to review those and that's something we strongly recommend is getting a software to review files that either you download, which is also available. There's tons, thousands, maybe millions of 3D printing available models online. So you're always going to want to review those and make sure that there's not holes and things like that. And there's some software packages that are available in this open platform world that can give you some advantages there. But in general, you're going to get a file and you're going to take it into either a review program or maybe skip that and go right into a slicing program. And basically, a slicing program is giving you the option to work on all the settings of your print, especially in this open platform world. I can change the info, which we discussed. I can change the layer resolution, which is the kind of the look and the exterior finish. I can make the wall thicknesses different. I mean, there are probably thousands of combinations of things that we can all control with our machines in this open platform world, which is a really powerful tool. So when you think about that many variables, it does take some experience to get your hands dirty and understand kind of what you're looking for there. But you in general, you take it through the slicer and then you program it to print. And there's more factors to it. It's definitely not that easy, but that's kind of the general steps we're going through.
You see the printing bureau side too before you get to Peter. Is there similar areas you're seeing as far as process goes?
Yeah, absolutely.
So different perspective maybe.
Yeah. So for us, we're normally generating a CAD file, so just a 3D model of a part. You export that as a specific file type. We typically use STLs. Then you bring that into your slicer program. There's a multitude of free ones. Ultimaker has a fantastic slicing software, Kira, that we use. And then what that slicer does is breaks down your CAD file into individual parts. So individual layers, you can obviously adjust that layer height, but typically around 0.2 millimeters or so. And then that exports it onto an SD card or directly to the printer itself, and press go.
Wow, fairly easy, Dan, right?
Yeah, it's straightforward. Of course, there's a lot of nuances and thousands and settings that you can tinker with, but
right.
A lot of times you don't have to. You can use the pre-described or preset methods and materials. So
yeah,
I think we're moving towards a world where you just hit print and then it should just work. So in the slicing software, you also do material settings. So that's like the temperature that your nozzle is going to print with, or the temperature that your bed's going to print with. And being open platform, you can just choose, a predefined profile. So if you're printing polycarbonate, whatever, you can just choose polycarbonate in your slicer. And then when you hit print and to send it to the printer's already going to know how to optimize the prints so that your polycarbonate print comes out the way that you want it to.
And that's the one advantage that I think closed source has traditionally had over open source. And what they'll utilize to say that it's superior is that, you can just click print and it should work. But if we're utilizing this for manufacturing and engineering, why would you not want to be able to modify your settings? There's no other process that these companies would be utilizing that isn't modifiable. You should be able to make those changes and be able to do all of these different things cost effectively without having to only have 3 material options and only be able to have certain wall thicknesses, because that limits the actual parts you're able to print to like 5% of the possibilities. So why would you want to do it any other way?
Right. There's an advantage not having to do that. I guess the versatility again.
Mm-hmm.
You can try different things.
Absolutely.
Right? It's good to note that like each material that you use, this material supplier has different printing recommendations. So just because one ABS prints at a certain temperature doesn't mean the next ABS prints at a certain temperature.
Mm-hmm.
So being able to freely adjust your settings according to what material you're printing really opens up the possibilities as well.
Yeah, I think we talked about that a little bit. ABS is a good example. Materials might be a little different in the 3D printing world than they would be doing a part in heavy production anyway, what you're getting out there. So you have to test some of this, right? It can be a little different properties, and how it comes out in the finished product might be a little different.
Well, and even from one brand ABS to another brand ABS, they'll be marginally different, and you might want it to perform a little bit differently as well. You can, if you're taking a translucent material, for example, you'll get significantly better clarity if you print it at a substantially higher temperature. Being able to modify that to have one material perform in a variety of ways is an advantage as well.
Well, sure. That makes sense. Well, we talked a lot about the benefits and how helpful this is, but we want to talk a little bit about the limitations too, because there's if nothing else, there's some areas that anybody using this should be aware of, and then they can get around it, obviously, and make their experience a lot more beneficial, advantageous, and help a company move ahead as far as they go on 3D printing. So we should get into a little bit, talk about some of the obvious and hidden limitations with some of this too, as we talk on the flip side with this. A little bit is even a lack of knowledge or skill set using some of the software programs. Are they fairly complicated, or is that something that is fairly easy to learn?
So you can get complicated. There's hundreds and hundreds of custom settings, but a lot of these slicers, Kira, for example, has a recommended easy mode. So for someone who's not exactly a 3D printing expert, they can just choose the quality, the layer height that they want, and choose whether or not to enable support, and then just a couple of check boxes and hit print, and then they should be up and running. So it even though to be an expert, there is a little bit of a learning curve to get your first print. We've made it easy. Like the 3D printing community has made it very easy.
Mm-hmm. It's sort of like having a digital camera. You can use the automatic easy button on it, exactly. Or you can use all the settings with it and adjust that too, right?
Exactly. Yeah, it's just like a digital camera.
Yeah. And then there's also different types of machines too that you can get. I mean, there's a whole gamut of machines that you guys sell and others sell too. That also takes some learning too. What might be the best for might be the best fit for your application, I guess, right?
Right. I mean, there's hobbyist machines that you can get very cheap, and then there's more industrial size machines.
Right.
They all have different benefits and advantages and disadvantages. So it's really up to the person doing the 3D printing to kind of do a little bit of research and figure out, this is the best machine for me. This is the machine that can print all these materials that I'm looking for. My application is this. I need to print this material. Can this machine do this material? If not, then maybe I need to look at a different machine.
Yeah, there's not a one-size-fits-all printer. There's not even a one-size-fits-all method. Outside of extrusion printing, there's stereolithography and selective laser sintering, and you can't just get one printer and expect it to do everything you could ever imagine, because there's strengths and weaknesses of everything. Dan was saying earlier that you wouldn't buy just one CNC machine to do everything on your machine shop floor.
Right.
Different capabilities and different build volumes, and the Ultimaker build volumes approximately, it's 12 by 12 by 12, right?
Roughly.
Yeah. So if you're trying to print a substantially larger part, then you're going to either have to modify that actual part itself or the way that you would print it, or get a different printer. Or if something else is more important to you, like the resolution, being able to obtain a certain level of resolution or dimensional accuracy, then the choice for printer, might change.
Mm-hmm. You find that with your customers,
Absolutely. Justin? I mean, we talk to a lot of people about, what our conversations are generally starting. What are we trying to do, and what's the scope? What's the next year look like? Because we find a lot of people who are going to start with a hobbyist printer and say, or they even have one, or they're going to buy one. And they say, what do you recommend? So we make some recommendations. We have that discussion. And then within 6 months, they're back and they're saying, all right, what's the next step? What's the next level? Where do we need to go? And we're just so thankful in this open platform world that there are so many options now. And each of them has their own quirks, and some of them perform extremely well, and some are in that same vein of you get what you pay for a little bit.
Right.
And then we end up servicing them or help, but
sure.
What I will say, and I think we touched on community, there are so many great communities around additive manufacturing as a whole, and around specific printers as a whole. Ultimaker has an outstanding community online. So people, we always stress, we say, talk to someone before you buy a printer, talk to someone who's run it. If we haven't run it, talk to someone who's run it. Don't talk to a salesperson always. Talk to get a feel from both sides of that. Understand what the capabilities are in reality, the challenges from their perspective. That adds a lot, because, like I said, we get the schools and libraries, and they come to us and they say, we bought this printer. Just don't, the challenges, or a business that we have one sitting on the desk and we just don't know what to do with it. It's so hard to work with. And I think there's a lot more research that can be done before that purchase is made. we really love to talk to people before they buy printers.
Oh, sure.
To kind of coach them through that.
Yeah. I imagine you get that with the printing bureau too.
Yeah. I mean, to me, some of the biggest downfalls is underutilization. 3D printers are very capable, and Justin, as you were saying, the research of what you need it for is extremely important ahead of time. And then one other topic along this line is that a lot of the closed platform systems do come with maintenance packages and everything like that. So somebody will come visit, make sure that your machine works. Your open platform systems, you either need to repair them or go to somebody like Justin and have it redone. And that can be a little daunting. The systems themselves really aren't that complicated, but knowing when to change things, changing bearings or changing belts, things like that. You do have to do that on your own, and something to be conscious of.
Yeah, and we already talked about materials a little bit, awareness of different type of materials, and we mentioned garbage in, garbage out. Basically, you have to start up front with the right type of design, geometries, materials, all of that, right? To make it work.
Yeah, absolutely. There's definitely different ways to design parts if you're going to be using additive manufacturing to produce them. You can design something that has hollow voids in it, or you can do variable wall thickness, which was very difficult for plastic injection molding. And then, of course, the infill topic. So you can say, I only want my part to be 20% dense. And so just understanding that you can completely open up your design tools to get an optimal 3D print is very important.
Yeah, what's interesting too with this industry is a little bit of the Wild West as far as best practices go. Yes. There's not standardized best practice or standard group that says this is what you should be doing. Is that an issue in the industry? Whoever wants to handle it? Yeah. Justin.
I think we can all speak to that. And we kind of touched on different types of even STEM variants of the similar material, ABS and things like that. And we have examples of where we have different colors of material that print differently. You can believe that. So that can be challenging.
Sure.
Yellow, I'm calling yellow out. But there's that. And then there's, there are some industry practices that are kind of becoming known for higher end industrial materials like PEEK and Ultem. And then there's, we had a project where we did something completely opposite of what was recommended, and that worked. So, I can't speak enough to the idea of, researching the printers and the technologies that you might want in that realm. And I know it can be kind of a barrier to entry, but talking to the people that run them, and go to your local service bureau and talk to people is so important. And that really I think that gives you 6 months of advantage, I would say, easily, and saving you headaches and saving your operation time.
Sure. Along with the communities that you mentioned too, that you work with a lot of this, right?
Yeah. And that portion of it is absolutely huge in selection. Like, no offense to Ultimaker, but the last person you should be asking if you should buy an Ultimaker is Ultimaker.
You say that.
They'll tell you yes. They'll tell you there's a little bit of a 3D printing sometimes gets a little bit of a bad name because the parts that will be shown by companies or examples that will be given are parts that are already optimized for the process. And that's huge. Optimization of design. You can't take one part that was designed for plastic injection molding, reverse the process and make it in a completely different way and expect it to be exactly the same. You're going to have some pitfalls. And to be able to find out, okay, this is my application, this is what I want to do with it, and then using that to make a printer decision is absolutely huge. And that's a majority of what we actually do with Holland in the 3D printing department now, is saying, okay, this is an application-based decision. Tell us what you want to do, all the different things that you want to explore. And our answer might be 3 different methods and 3 different printers,
right?
Because they'll do completely different things. But you need to ask a very unbiased source what you should be doing, because the answer is not always going to be one printer, one way, one setting, one part.
Yeah, if there's anything coming out of the discussion, it's the fact that you need to be versatile, that there's nothing's off the rack, nothing. It depends on the application in a lot of cases, right? What you're doing with this. Which leads to another possible barrier, but something at least to think about, is go back to the talent question again we talked about earlier, and that's, I imagine, hiring the right people that know this, or having enough people on staff that can do this kind of thing. I'm talking about a processor or a manufacturing company of some type. Those issues that you've seen out there, especially Dan and Justin, I guess, anyway.
I guess since I'm on the smaller business side of things, we do the printing ourselves and do everything ourselves. But one thing to kind of note along that is that a lot of times on complex prints is that you need to remove the support structure around the print, and that can be a time-intensive process. And
the supports, maybe better explain that a little bit.
So if you have I guess I'm going to borrow your part here,
Sure.
Peter, but
we've got some toys here too to show.
So if this part was printed vertically, so starting from the bottom and going up, you can't print from thin air. You've got gravity to deal with. So all the area under here for if you're using just a single extruder printer, you'll have something called a support structure, and the support structure would go all over this part, and it would take a very serious amount of time to actually clean it all up and do a good job to ensure that you have a good surface finish. There's ways around that, which I'll let you discuss and go through.
I can jump in. So this part in particular was printed with water-soluble support. So that means you don't have to manually go in and break it off, because if you were to do that, then you'd have a lot of stuff that you might need to file down to get a clean surface finish. And then on the inside of that, where you have all that complex geometry, you might, accidentally break off some of that geometry. With water-soluble support, you can use two nozzles. So you'd want to get a printer with dual extrusion.
Sure.
And in one of those extruders, you can print with PVA water-soluble support, and you just put that in tap water, and it'll dissolve away. Lets you do more complex geometry, deep cavities, things like that.
Wow.
And so it may be a little bit of a different way to answer the question of people, but using different methods on your printer, you can actually reduce the amount of labor that is required to to use.
That's a different spin on it. You may not need as many people, but you still have to have somebody on staff, I imagine, who knows it somewhat, right?
Absolutely.
And it's worth the time, though, too, because one of the biggest problems in manufacturing right now is a lack of people. Machinists is a huge deal.
Yeah.
There aren't enough skilled laborists to operate these CNC machines. And to take an application like jigs and fixtures, for example, if you turn that into a hands-off process, meaning, yes, you have to have somebody to click, print, and load the material, but you can very passively make these jigs and fixtures while you're doing other things. You can click, print, and it'll go overnight or go over the weekend, and you come back to a finished part. And there might be some support material removal depending on the design, but it is an educational process. Yeah, you need to understand some things about 3D printing. You have to know how to turn it on and operate it and things like that. But it's worth the investment to get your employees that education and to find those resources to educate your staff on how to do those things.
If you get in touch with the right people, then those people should, be able to train the staff on how to use a 3D printer. It's just a couple of hours to invest, but and then just getting used to doing it and getting experience. And with experience comes expertise. Yeah. So it's really not that difficult. You just need to set aside the time to do it.
Yeah, I think we talked about before too. About you mentioned underutilized printers and also over expectations over things that they're expected too much of. Right. You expect too much, but you underutilize at the same time. Right.
Yep.
With this.
Yeah, you can't. If you're going to try to produce 10,000 parts of something a year, 3D printing may probably not be your best solution. You also have to understand that the material properties are not usually quite as good as an injection molded part. You've got layers to deal with and then delamination on those layers. So you understand that the strength properties maybe aren't there. However, there are a lot of fantastic materials that you can get that hold up surprisingly well in a number of applications. So
since we don't have that much time left, the only other point I want to make is that really we've talked about some of this. You maybe seek out professionals as you guys are to help with some of this anyway, and that's obviously key to getting around some of these potential frustrations, I guess, that you might have, right?
And I think unrealistic expectations is something that every single one of us can speak to. At one point in time, I had somebody bring me a part, and it was an underwater actuator, and they said, I want to print this, and it's going to be subjected to 10,000 PSI in all axes, and I want to make it out of nylon. And we're like, that literally just cannot be done. It's going to blow up. It's going to fail. And sometimes the answer, and a lot of times the answer is no, this is not the best solution for you, but being able to identify that and having realistic expectations. The biggest mistake I see companies make is saying, oh, well, I heard, company X over there bought some 3D printers. We're going to invest a couple $100,000 and just, buy this 3D printer. we're just going to buy it. And then I've seen that happen so many times. It's not even funny. And you come in and this machine hasn't even been plugged in, hasn't been used, and nobody knows what it's for, or they're, just putting toys on it.
Yeah.
And there's so many different things that you can do that actually, going at it from an application perspective and being very realistic about the properties that you're going to get and when it's the appropriate time to choose this for your process is huge.
Oh, sure. So it's not just a big block of metal in your factory, right?
It's not always going to work. It's not always going to be pretty.
Yeah, and that we've seen a little bit, right? You guys talked about this earlier, that they buy this piece of equipment and that's just sitting there. They're not using it, right?
Absolutely. Happens all the time. Yeah. We get calls to buy machines constantly from companies and schools. We don't know what this thing is.
We're in the business. So seek out your professional, obviously, and there's forums. I know that you guys have also that can address some of this, right?
Exactly. If you have a problem or an application that you need help on, ask the community, utilize the community, utilize the experts. We are all, the 3D printing community talks to each other, and we're all kind of helping each other to all succeed. It's not really that cutthroat type of thing. It's like, I tried this and it worked, so I'm going to tell you what I did so you can also get it to work as well.
Sure.
So we have forums, we have, if you're looking for a certain feature in a slicer, for example, in an open source slicer, you can just request it directly with the developers, and we can try to get it in. Other people can try to write their own plugins for you, even if it's not the official developer. So we're all just here to help each other.
Sure. Well, and in the few minutes we have left too, before we get to questions, we'll talk about applications a little bit. And there's obvious. First of all, you get the media. You get 3D printed houses and cars and all those kind of things. You see, wow, you can do this. But that's not realistic. We're talking about for plastics industry, the kind of things that you might want to look at, how it fits into your product life cycle and everything else with some of this. And I know but jigs and fixtures are a big one, right? Is that maybe one of the predominant areas we're seeing with the application with this?
Well, yes, yes. Jigs and fixtures for sure. Manufacturing aids, quality assurance gauges, tool organizers, anything on the production line, the manufacturing floor. Not necessarily the end use part. You can do that if you want. We already talked about that, but everything before that too, even if it's the smallest connector that you can print for a couple of cents rather than purchasing it from somewhere and waiting 3 weeks for it to come. You can just design it and print it within like an hour. You'll save time, and then you can reinvest that time to do more engineering work.
Right. So it's just a piece of something else.
Exactly.
Well, and I mean, as we've discussed, the prototyping is huge. Engineering development, 3D printing can play a huge role there. And then I guess end product customization. So there's a few automotive manufacturers that are actually utilizing 3D printing to allow customization of your vehicle. So little plastic parts that you can swap out of the car and put your name on it or a smiley face or something, and then and put it on. And they do it within 3 or 4 days. And then even pushing that further is there's another car manufacturer that for a lot of their old vintage cars that maybe they made 100 of, and the tooling and maybe just the manual labor doesn't exist to make those parts anymore. Well, they can scan one off an older car and then you can reprint it and add your own material texture to it if you so choose, and so you can do a ton of customization.
Wow. Well, we have a ton of questions, so I got to break it off there, I think, a little bit and get to all the questions that come in. First question is, with open source 3D printing, does it come with a special software, firmware compared to closed source? Is there differences there?
You can use whatever you want.
Okay.
Yeah, so it's in the definition. So that means you can use whatever slicer you want, and you can download the ones from the manufacturer if you want, but you can use any third party. You can use any third party material. You can use any third party modifications. So that's really the beauty of open platform, just doing whatever you want.
Great. Here's a question too. Concrete. Someone at University of Kentucky researched the 3D printing of concrete. And maybe we can talk about other kind of materials that are kind of off the beaten path a little bit, besides concrete anyway.
Sure.
Any experience with any of that?
Yeah, the concrete. Concrete is going to be something that will be impactful.
Yeah.
We're seeing more of that. That's not something I would say anyone outside of maybe 10 companies in the world are really going to be doing anytime soon.
Is there anything off the other side, otherwise off the beaten path that
we're using industrial hemp?
Industrial hemp
in in Colorado.
Well, you make sense.
Yeah, we have a hemp-based material that's the customer's seeking, certain properties there. There is some strength properties, to be honest. But I mean, I have 150 materials in my shop, all variations, all different kinds and colors, but strength and different things. There's so many materials available these days. It's really cool.
Yeah, really and I don't have experience in printing concrete, for example, but as I mentioned earlier, you can get things with wood infill, so you can actually sand it and make it look like a real wood part.
It smells amazing.
Yeah. you can have coffee coffee infilled stuff. So when you print, it smells great.
That's great.
Of course, different metals infused into your plastics.
Metals is huge.
Magnetic components.
Wow.
You've got conductive.
Yeah.
So there's tons and tons of options.
And that brings the next question. How about glass filled? Can that be done with this too?
Glass filled is actually a huge one of Holland's materials is the Owens Corning X strand. So Owens Corning being fiberglass,
Right.
and it's an incredibly abrasive material, but because it's abrasive, it's strong. And so some of these filled plastics, just like in the plastic injection molding world, are increasing the strength properties, and they're a little bit more difficult to print, and sometimes require some other modifications. Like on the Ultimaker, they just launched their CC core, which has hardened metal components that allow for these abrasive materials to be run through the printer. But actual glass too exists. It doesn't print very well, but it exists. And all of these things are being explored further and further in development because there's a need for it.
Wow. So what compromises are there using open source printer due to the wide variety of material sources from the same material? It may process slightly differently from different suppliers. We talked about some of that already, but are there any other compromises with some of that?
Maybe it
depends on the application.
Honestly, it's just adjusting your settings. One material manufacturer to the other, they're going to be a little bit different. Maybe you have to offset your nozzle temperature by 10 degrees or your bed temperature by 10 degrees. They're usually pretty similar, but that is a compromise. You're not getting a uniform product across all manufacturers.
That's very true.
I'm
sure.
But would you want to spend an additional $65,000 to save 10 minutes? Probably not.
Right.
Yeah.
Find that out, right?
Exactly.
Yeah.
That's the advantage of it, is being able to test and see what works best.
Yeah.
This is like a futuristic Jetsons type of question here, but will 3D printing ever become the preferred manufacturing method versus mass production methods like machining or injection molding or something? Are there a lot of hurdles to be overcome to get there? I imagine that's a ways out. But,
yes and no. The no, to me, you're still always going to be stamping sheet metal parts. I don't think printing is going to take that and change that dramatically in terms of your end product. That being said, you could print your actual stamping fixtures. I've worked with a company that we printed a Ultem stamping jig and used that and made hundreds of prototypes of pretty heavy gauge steel parts. So you may not have an end product that's 3D printed, but the influence of additive manufacturing to make something is pretty unique.
That's absolutely the case. It's never going to replace traditional manufacturing. Yeah, the 3D printing is getting better. It's getting faster. The materials are getting better. It's getting more consistent. But this is not intended to replace plastic injection molding. Right. It's not intended to replace machining. Especially in the case of like the industry that we're in is molding. Imagine being able to cut your molding tooling costs into 10% of what you're currently paying.
Right.
You can in some cases print usable temporary prototyping molds. You can print the positive of a part and have it cast and actually create the mold for just hundreds of dollars as opposed to tens of thousands of dollars. And so this is to be viewed as a tool to enhance your manufacturing process and reduce your costs and increase your speed, but not to replace it in a lot of cases.
That's not really the mission of it, to do that. It's really to enhance what you're doing and help with the prototyping and the innovation area and some other things we talked about anyway that go on with this. Right. Question about open software. Maybe that's good for Peter here. Do you have to send your files to an outside entity, or can you adapt your 3D printer to whatever open software you like?
You don't have to send your file elsewhere. You can do everything locally. You can download whatever software you want and locally slice it for your printer. There's nothing that you need to share with anybody in case you're doing proprietary type stuff.
Most CADS files can be saved as STLs, which is the universal, pretty much every computer can run on it. And it's as easy as saving a document as a PDF, right click, save.
Yep. And maybe one kind of note on the software, it's more of a computer power thing, is you don't need a supercomputer to do this stuff either. You can use just a generic laptop and you'll be fine.
Okay. Well, we'll have time for one more question, then some final comments. And this is a good question to ask for a final question here. If I can get to, in your experience, is there a general rule to follow when trying to determine if 3D printing is the right route to take with your components? There's a good general question for everybody. That's almost a good wrap up.
Ask someone. Ask one of us. Go to people like Justin and Dan and Peter and myself and ask and say, here's an application. Would this be ideal? Does this need to be redesigned? Because until it's commonplace and the education portion is there and it's everybody knows about it, then you're going to have to consult with someone, or you're just going to have to keep printing it till it works.
Right.
Exactly.
And maybe another thing on that is understanding what your tolerances are of that part. If you're trying to hold, cylindricity or, 1,000th on a hole or something like that, FFF printer is probably not going to be your best selection. There's other options, but just understand that, if you're doing precision 3D printing, it can work. You just have to be a little bit more sensitive on the machine you select.
Right. Just in 25 words or less as we go around, is there any last thought, last message you want to get across to the audience here today about 3D printing? I'll just ask that generally. Maybe Dan will start at the other end with you.
Last thoughts is I think try it. It's you can get a low cost printer and free software and give it a shot. If it's something that you think could be interesting for your company, and invest $1,000 or something like that, and maybe 20 hours, and you'll be able to be printing stuff. So
great, Peter.
Yeah, so there's a misconception that we're just printing, toys with 3D printers, where that's not really the case. We have so many different material options that can reach so many different applications. So really, my final parting words is definitely ask somebody, ask an expert. Any of us would love to come talk to you and show you exactly what you can really do with 3D printing.
Great. Haley Ann?
I think a misconception with 3D printing that has always been there is everybody's waiting for the technology to get there. They keep saying, it's just not there yet. Well, it is. You just don't know about it. So that would be my parting phrase is you have to get into it to understand how far it's come and how you can utilize it.
Great. And Justin?
One of our mantras that we kind of live behind, or we tend to experience, that wraps things up for what we talk about at our store, is we make things that haven't been made in 50 years or have never been made before. And so that's a really wide breadth of opportunity when you think about that. So there's a lot of materials and technologies and things that people can get into. But if you think about it that way, definitely talk to the communities, talk to people like us, and you'll be on your way.
Excellent. Well, our time is up for today. And I want to thank Justin Feinsilver of 3D Printing Store, Haley Ann Friedman of M. Holland, Peter Ho of Ultimaker, and Dan Lynch of Composite Drivelines and the printing service that you have in Milwaukee. Great discussion, engaging and illuminating, and maybe it'll give all of us in the plastics industry thinking more about open source 3D printing and how it can be used as we continue to grow with it in the industry. We appreciate your attendance today at this Fireside Chat, fueled by M. Holland and produced by Plastics News. If you want to revisit this chat, the entire event will be archived on the live stream webinar section of plasticsnews.com, so you can go there and find it. Again, this chat and others in the continuing series of Fireside Chats that we've done can be found on our website. Thank you again for joining us, and we're grateful for your support of this series of Fireside Chats throughout the year. Look for the next in our series of Fireside Chats in the fourth quarter. We'll talk again soon.